Hey everyone, I'd like to welcome you to the next episode of Math for the Impatient. I'm here with our CTO and co-founder, Stan Kladko. Hello, Stan. Today we're going to talk about the very, very exciting tech area that we just did an announcement around ZK. So I think, probably the first question is, pretty obvious question. What is SKALE ZK and why is SKALE doing it now?
Yeah, Marcus, this is going to be an interesting video. I think, first of all, I will need to explain a little bit about ZK and why we are doing it now. So Scale has always been about mathematics. And about computer science. We always tried to bring to our users the best mathematical algorithms and computer science algorithms. We run the best consensus, the fastest, we have fast finality, we have a pretty interesting blockchain, which is probably one of the most advanced blockchains ever created, and it's also Ethereum compatible, very fast. So it's normal for us to look into mathematics and computer science and see for some new things that we can add to our blockchain to make our user experience better. And one of those things is ZK. ZK, zero-knowledge algorithms, basically, essentially allow Ethereum mainnet to watch over Scale. And I'll explain in a moment what does this word mean, watch over. Let's give you a very simple example from the regular world. Let's say you are the CEO of Starbucks. Starbucks has offices in different places all over the world. The accounting is very complicated, different currencies, different taxes. And then at the end of the year, you need to calculate how much tax you need to pay, basically one single number. What's your total tax bill? But to calculate this number, you actually hire a huge tax accounting company, and they calculate this for months, because there are lots of formulas, tax laws, whatever. And then they bring you the result. And the result is simple, just a number. Here's how much you need to send to IRS. But to calculate this result is a huge computation. And then the question is trust, right? How do you trust these people? How do you know that they actually use the formula correctly? Because you can't repeat every single computation they did. So in the real life, there are different strategies people usually use. The simplest strategy is sampling, right? Like let's say you have 1,000 Starbucks offices and shops. You could just randomly select 3 of them out of 1,000 and recompute yourself the accounting and make sure that the guys actually told you the right number. So sampling is great, but the problem about sampling is that you can't sample everything, and what they can do to actually work against you, they can take a single Starbucks shop and make it, pay a zillion in taxes. And so because you didn't check this particular Starbucks shop, your accounting may be totally off. So sampling is great, but it doesn't protect you totally because the things that you don't sample could actually have huge difference. So that's the simplest idea, sampling, and many people use this sampling in their life, right? But there's mathematically a more interesting idea. Let's say before you give your numbers to the accounting company, you make sure that every dollar and cents, all of these numbers, say are divisible by 7. And divisible by 7 means like 14 cents, 21 cents, $7, anything which can be exactly divided by 7, by integer. So let's say what you give them, every single number, there are zillions of numbers to give them, but every single check, every single bill is divisible by 7, and they don't notice it. And then they try to fool you, but you know that when you add 2 numbers which are divisible by 7, the result has to be divisible by 7. And when you multiply 2 numbers divisible by 7, the result has to be divisible by 7. So basically, you know that the result these guys need to bring back to you, this number, this huge number the check that you need to send to IRS, needs to be divisible by 7. So when they bring you the result, you divide it by 7, and if it's divisible, then you have an assurance that they did a good job. but it's not divisible, it's clear for you that there was some error, is an error, or they on purpose did something wrong. So there's this interesting idea about, and they may not know this. It's not so secure because if they are smart mathematicians, they might notice that everything you've given them is divisible by 7, but many people probably wouldn't care. And if they didn't notice it, then if they try to fool you, you will win. You will find out that the result is not correct. So this is kind of a very simple idea, which is not so secure because by looking at numbers, people can guess that they are divisible by 7. But this brings you to a more general idea that when you give something, your formula to someone else, you need to embed into this something hidden, some hidden knowledge, that when they bring the result to you, this hidden knowledge will be inside of this result, and you can check the result, whether the hidden knowledge is there or not. That's pretty much a very high-level idea of zero-knowledge proofs. Basically, someone makes a huge computation, brings the result to you, and somehow you force them to include this hidden information inside, which actually lets you check whether the result was computed correctly. So that's pretty much the idea about zero-knowledge proofs. And actually, people are now trying to use the things for taxes, believe it or not. One of the applications of zero-knowledge proof is to calculate taxes. But this can also be used on blockchain. And on blockchain, what it means is that every calculation you make on Ethereum is very expensive. And every piece of data you publish on Ethereum is very expensive. But so Scale cannot just take its entire blockchain and all of the calculations and data and just post to Ethereum and tell Ethereum verify. But with zero-knowledge proof, all of the calculations that we are performing, we can push the very tiny result, something which is now called the zero-knowledge proof to Ethereum, and the Ethereum mainnet can verify that our calculations are correct. Now, this is kind of the idea about zero-knowledge. But another thing to understand about zero-knowledge is that every startup needs to pick new technologies. But you pick a technology when it can be used by people without totally destroying user experience. So we've been looking into zero-knowledge for quite a long time, for the last several years. And on every occasion, we saw that it was too slow, basically too slow, too complicated, and essentially that would kill user experience. Yes, we could take Scale and make it verifiable on Ethereum, but things would become so slow that we wouldn't be able to do things. And we didn't want to break the great user experience people have on Scale. We have, as you know, several seconds of fidelity time. Things happen almost instantly on Scale. Now, for the last couple of years, two things happened, three things actually. One thing that have been tremendous breakthroughs in the zero-knowledge mathematics. Number one, so things became faster, and nowadays they are probably like 1,000 times slower than regular computations, which is more or less okay. So you can do them reasonably fast. The second thing, there's lots of open source, and there is lots of cryptographic libraries and things and tools in zero-knowledge that a startup can use. And the third thing, we figured out some unique ways in which we can make things faster without breaking user experience. We wouldn't just add ZK as a way to just put a ZK word on Scale. We wanted to be able to contribute something unique. And at this moment, we think that we can do this unique contribution, meaning that we can verify Scale chains on Ethereum and without breaking the user experience. So users are used to paying for things fast, getting fast response from dApps, and we want actually things to become even faster. So we think we can do it. And once we realize that we can do it, we make a decision that ultimately all of Scale will be ZK enabled. It's a road with multiple steps. But the long-term vision that on every Scale chain, you will be able to use ZK. This means that there will be information posted about Scale to Ethereum mainnet, and Ethereum mainnet will be able to verify scale. This means that even if all scale nodes are compromised, you will be able to use Ethereum as the source of truth and actually recover your money. So definitely, we do understand, and it's one of the things we also heard from the customers. People do perceive Ethereum mainnet as probably the strongest in terms of security, in terms of the amount of money staked there. So being able to also add the security to ETH mainnet is important.
So you talked, talked a lot about ZK there. It's all super interesting stuff. Can you dive a little deeper in how SKALE ZK is going to work?
Yeah. So again, we've been looking into ZK, but we were waiting until we can really find something where we can contribute. And so we've been looking into the first generation ZK solutions, and we saw them as slow. So we've been trying to understand how to do things better. And so as the first generation ZK, the way it works is basically people submit transactions to someone which is called an operator. The operator basically compiles these transactions. The operator is supposed to also have very powerful computer, roughly probably from 100 to 1,000 servers to make things fast. And the operator is actually combining these transactions and does all of these computations, and then ultimately posts the results, the zero-knowledge proofs, to Ethereum mainnet. And only at the moment when they are posted, the Ethereum mainnet is verifying them, and then they're basically final. Which means that if you send me $10 with the first generation ZK rollups, you need to wait for the operator to process this $10. Then the operator submits, computes the proof, submits the proof. The proof is posted on the ETH mainnet, which is like a couple of minutes, 10 minutes probably wait time to make things final. So roughly 10 minutes plus the computation time. This is the time you need to wait. With SKALE, we already have a blockchain, and our blockchain is already pretty secure. So when you send the money, you send me $10 on SKALE, things will become final in several seconds. So literally, you'll see, okay, I paid, and I'll find out that you paid, right? So there is this fast finality time on SKALE. But then we're gonna also take the same computation and also compute the ZK proof for it and post it on Ethereum mainnet. And so this computation may take more time, and then there's a 10-minute wait time on Ethereum. But then it will be all up to you whether you wait or not. If you send me $10, probably security of SKALE is enough. If you send me $1 million, you can wait like 20 minutes to actually wait until it's finalized on the Ethereum mainnet. So for first generation rollups, there's one finality time. Things become final when they are posted on Ethereum mainnet, no matter how big the transaction is. For our rollup, there are two finality times: SKALE finality time and Ethereum finality time, the ZK computation. So you as a user, it's up to you to decide how long to wait. And if you are okay sending $10, just waiting on SKALE, you don't have to wait. So it actually creates lots of flexibility. Essentially, it doesn't slow the blockchain, our blockchain, because users that do modest transactions don't have to wait. And people that send millions of dollars, probably for them waiting at 10 minutes is not so big. And then another thing which is really huge is that because we have a network, the computation can be done by the network, not by a single operator. So it's almost for sure that our ZK computation is going to be distributed. All of the nodes in the network will participate in the computation. And then this essentially means that things are collaborative, and not a single node needs to be a supercomputer. Instead of having a single supercomputer, we can have a large-scale network and small guys putting things together. So we're back to the original idea of blockchain, where it's a community. It's not just a single guy that has 1,000 servers. the network, and we just need to find the right way to incentivize nodes in our network to do the computations.
Great. So I think that's the last very quick question. What are the timelines?
So there will be a sequence of steps. As I said, ultimately all scale chains will become ZK enabled, but we need to start with something. So you can probably deduce that initially there will be maybe one or several chains, and then we'll kind of propagate this, which this is kind of, I think it's clear. And then the second thing, we are going to start including some ZK features, pretty much starting from release 2.2. There's some cryptography which we need to implement. There are some other things. So we're not going to wait. There will be, starting from scale 2.2, there will be some features added to the product to ultimately make it totally ZK aware. But this will be a road. But we definitely think that the year 2023 is the year of ZK for scale. And we are totally changing everything inside scale to be ZK aware and to use ZK technology. It's a totally next big thing for us.
Awesome. Great. Well, we got all the scoop and the skinny and the alpha on ZK. Thanks everyone for joining us. Look down. You can join us here on YouTube. You can join us on our Twitter at Scale Network. Also, please join our Discord and our Telegram. Thanks a bunch, Stan.
Bye, Marcus.
Bye.